Programming language. Hello learners. We need a language to communicate. In the same way, computer needs the language to communicate with the user and processor to take and execute the instructions that is known as programming language. Typically, a programming language has its own vocabulary and a set of syntax rules that the programmer must learn. Languages have gone through the several facets of programming language generations, that is, the indication of increasing power of programming styles. Let us discuss the different generations of programming languages. First generation languages. Machine languages, one of the most basic and primitive languages, are designed for a specific type of computer processor. Since these languages were developed in the early days of computing, they come under 1GL. The features of machine languages are 1. This language is only understandable by computers. It comprises of the sequence of binary patterns in the form of zeros and ones, which directs the activities of a central processing unit. Naturally, this language is difficult to understand for humans, not for computers. 2. There is not any universal machine language because the language should be written as per the characteristics of a processor. Each category or family of processor necessitates its own machine language. Due to this reason, this language is not portable. It is machine dependent or hardware dependent. 3. The set of instructions written in machine language consists of an operation code and possible operands. The operation code directs the CPU to perform the sequence of operations and operands, specify from where to get the required data to do processing. As an example, 1010, 0011, 0001, 1001 is a machine language. ADD R3, R1, R9 is an assembly language. Each instruction has a specific format with two fields: opcode or operation code and address. Opcode indicates what operation is to be done, and address specifies the memory location wherein the data is referenced. The length of each instruction is 12 bits long, in which 4 bits are used for opcode and remaining 8 bits are for address as shown. Second generation language, 2GL. To make software development easier and efficient, the assembly languages were evolved. They are also classified as low-level languages because detailed knowledge of hardware is still required. Assembly languages are based on mnemonic operation codes such as MOV, INC, SUB, ADD, MUL, START, and symbolic addresses in place of ones and zeros to represent the operation codes, and thereby are also known as symbolic programming languages. A typical assembly code line is shown below. Label, opcode, operand 1, operand 2, comments. The first field is label field that is optional. Label specifies the symbolic labels and constants. The next field is the opcode or mnemonic field. The third and the next fields are for the set of operands. The comment starts with the delimiter semicolon and ends in the same line. These symbolic programming languages simplify the programming task because the programmer needs not to remember the exact storage locations of instructions or data. However, because they are also machine dependent, assembly languages are not easily converted to run on other types of computers. Also, an assembler program translates the assembly program into machine language. Instruction set in assembly language is of the following types. A. Data transfer instructions. To transfer data from one position to another, that is, data transfer from register to register, register to memory, memory to register. Some data transfer functions include MOV, move, MVI, move immediate, LDA, load accumulator directly from memory, STA, store accumulator directly in memory, LHLD, load H and L registers directly from memory, SHLD, store H and L registers directly in memory, XCHG, exchange H and L with D and E, XTHL, exchange top of stack with H and L. B. Arithmetic instructions. These instructions are used to add, subtract, multiply, increase or decrease data in registers or memory, like ADD, add to accumulator, ADI, add immediate data to accumulator. C. Logical instructions, used to perform logical or Boolean operations on data in registers and memory. ANA logical AND with accumulator, ANI logical AND with accumulator using immediate data. D. Control transfer instructions, to jump from one part of program to another and for controlling the loops or iterations. The instructions are like JZ, jump if 0, JNZ, jump if not 0, JMP, jump, and many more. JMP L12, jump to line 12, JNZ L12, jump to line 12 if not 0, JZL 12, jump to line 12 if 0. E. Stack input output instructions, PUSH, push 2 bytes of data onto the stack, POP, pop 2 bytes of data of the stack. Third generation languages, 3GL. The earlier high-level languages were developed around 1950s. High-level languages use a rich set of syntax constructs that give flexibility in program design and are easier to use than first-generation languages and second-generation languages. The compiler or interpreter programs are used to convert high-level language program into machine language. One of the prominent features of high-level languages is their portability on different hardware platforms. Since the 1950s, many different high-level languages have been developed and they vary in design based on their purpose. Some examples of 3GL are BASIC, Fortran, C, C++, APL, COBOL, Modular 2, Pascal, and Perl. With the advent of the internet, new programming tools like Java, JavaScript come into the domain of programming to go hand in hand with internet browsers. Fortran, one of the first high-level languages, was designed for scientific uses. COBOL is often used in business, and C or C++ is used for application program development. Fourth generation language, 4GL. The 3GL requires the sequence of steps to indicate the order in which they are to be executed. Due to this reason, these languages are called procedural languages. Some newer languages have no such specificity. They are known as fourth generation languages, or 4GLs, and are non-procedural declarative languages because the user can tell the computer what to do without being so specific about how to do it. 4GL evolved with the proliferation of relational database management languages for report generations, forms designing, mathematical optimization. They are used to organize the data and print out reports based on the stored information. A database query language is an example used to serve this purpose. Fifth generation language, 5GL. The next generation of programming languages employs query-based methods, also referred to as fifth generation languages. 5GL methods generally do not have the syntax requirements as in 4GL. The programming becomes more like normal human language in 5GL and is easier to use than 3G and 4G languages. The text of 5GLs closely resembles human speech. 5th generation languages are used mainly in artificial intelligence research. Prolog, OPS5, and Mercury are examples of 5th generation languages. Thank you and see you in our next section.